Hello, hello, welcome back to our last talk on the observability track of What the Fuck is SRE 2022. Kudos to you if you made it this far with us. But hang in there, there's still one more very interesting keynote. And before we kick off our last talk of the day, I'll do some housekeeping. Please play nice and follow our code of conduct. You can take a look at that in the chat section. My amazing co-host, Charles, will drop all the necessary links for you. And don't resist to fill in our form on the Hopin main page if you see someone violating that. And Charles will be following the Q&A tab for your questions. So yeah, please make sure you use that. And I'd like to give a shout out to our amazing sponsors, Blameless, Stormforge, Teleport, Cortex, Shoreline, Lightstep, PagerDuty, Fire Hydrant, and Rootly. And I'd like to welcome Ricardo Ferreira for this last talk of the day. We've been expecting to hear from him since, since the day we received the call of papers. So yeah, down to the rabbit hole with the OpenTelemetry agent. Ricardo, the stage is yours.
Thank you. I appreciate it. And for all of you that are participating of this conference, I'm pretty sure that at this point, most of you have a clear idea about what the fuck is SRE. So, and this is at least my hope, right? At least I am having right now. So thanks everybody for being here today. This talk is going to be about OpenTelemetry, observability, of course, but specifically about OpenTelemetry and how the agent for Java allows you to do some tricks that sometimes are not so obvious, but we are going to actually discuss all of this here. This talk is actually the result of my personal experiences using the agent for something that I've built, and also the result of the work that I've been doing with the community and helping developers to kind of instrument their applications, their microservices. And I've fortunately or unfortunately, I've found some kind of tricks that you sometimes you have to use it, and that's the whole point of this presentation, right? So to get things started, I would like to introduce myself properly. For those of you that don't know me, my name is Ricardo Ferreira, and currently I'm working as a developer advocate at AWS. Before this, and some of you might have seen my title from the introduction, I used to work for Elastic, and that was the place where I always had this feeling that observability was a cool technology, but when I worked for Elastic, I had a clear interaction with not only the technology, but the community behind it, and I fall in love with it. Like observability, I think that's the key technology that everybody needs to be using these days because of the inherent complexity of technology, right? And also, my areas of expertise are distributed systems, observability, of course, databases, and fast data analytics. And this is why a little bit of kind of got into observability, because you cannot live in a world where you are surrounded by distributed systems and not worry about, okay, what is the strategist doing? What is the processes that's going to be picked up next? What is this queue is actually processing right now? So that was the kind of the world that I came from that made me realize that I would need to learn a new technology for this, right? And this is my Twitter handle, which happens to be the same of my GitHub handle, and some of the code that I'm going to show here, it's there. So I'm going to provide links throughout the presentation, so don't be shy to take note of the link and then try yourself everything, all right? Well, I think it's more than fair to assume, given that OpenTelemetry is the brand new technology, like, yeah, we have roughly two years, 1 year and a half, 2 years of the actual project being adopted and construct. But the reality is that I've been seeing that most of the people are not fully aware about OpenTelemetry. So I'm going to give you a very quick wrap up. I'm not going to plan to spend too much time on this, but for the sake of put everybody on the same table, right? And the reason why I think it's important for us to be in the same table is because I've been hearing some complaints, and I think that's the word, complaints about OpenTelemetry being too difficult, right? And I don't believe this is true, right? I think OpenTelemetry is a very straightforward well-designed architecture and technology, right? But I think the main criteria that most people not pay fully attention about what OpenTelemetry is about, it is supposed to be a framework, right? So I think the confusion starts because if your observability is not necessarily a brand new technology, right? We have been having like tracing, logging, and metrics technology since forever. But if you came from this world and maybe you were exposed in the past to some agents or APM technologies, and you try to compare and contrast the same with OpenTelemetry, you may find that OpenTelemetry is a little bit more complicated. But the reality is that OpenTelemetry is a framework, right? It is not a technology per se, or is not a specialized agent that's going to give you everything right off the bat, right? That is more like a framework for you to build things on top of. And if you follow some of the cool vendors that are behind observability, you name it, like Honeycomb, Lightstep, Datadog, New Relic, Elastic, Amazon Web Services, they all are starting to build their own agents on top of OpenTelemetry framework, right? So, and this is kind of the modus operandi that most of the vendors are going to start to use it, because that's the practice that they use to make sure that they're in line with the spec and the technology, but they can actually provide the same experience that their own observability platforms provide. So, but the reality is, if you go by yourself and start using OpenTelemetry right off the bat, it's going to work, right? I'm not saying that's not going to work, but you might feel that you are putting your hands too much coding or configuration or customization. And just remember this, because OpenTelemetry is supposed to be a framework, right? So don't blame the poor old OpenTelemetry just because you're giving you too much headaches for the implementation's sake. So I like to joke that OpenTelemetry is a means to make your observability programmable, right? That's a way for you to write down your way out for data collection, data transmission, and data storage for all the signal types regarding telemetry data, such as logs, events, metrics, or traces, right? So it's just remember this is a framework, right? And also, like, just part of the wrap up of OpenTelemetry, you have to understand a couple of things that I think that are important. The first one is that when we're talking about the concept of agent in OpenTelemetry, there are two kind of distributions or two ways for you to see the agent. The first one is what we call the embedded agent, right? So maybe you were dealing with a programming language. That's another thing, that the way OpenTelemetry looks like depends heavily on the programming language and runtime platform you were using. For example, in Java, which is what we're going to see here today, has the concept of an agent, which can be kind of executed within the JVM, right? But other programming language doesn't have the concept of agents, right? So the agent is going to be more like a library or a SDK that you are going to incorporate in your code, and then is going to execute, we call it in process, which is along with the process of your application, right? So the first one is what we call the in process distribution mode. And what happens is that basically your application can send the telemetry data directly to the backend, right? There's a couple of assumptions here. Number one, the agent can be embedded in your application. This is something that you have to do this explicitly, right? So that implies that you have to change your code. The second assumption is that the backend itself has to support some of these supported protocols for an OpenTelemetry, namely OTLP, for example, right? So let's say you're dealing with a backend that doesn't support OTLP. What's your alternative here? So you can use the collector or the agent as a service. So it's going to be like this middleware where your application is going to send all the signal types and events to this middleware, and it's going to forward. Sometimes even there's some transformation processing all of it, but it's going to forward to the backend, communicating with the specific protocol of the observability backend, whatever the observability backend is. So this is also part of the confusion that I've seen about, for example, one developer can say, no, my experience with the OpenTelemetry so far has been great because I've just included this library and everything works. But the other one said, oh no, but for me it has been troublesome because I'm actually had to install this other meter here, and I have to do a lot of plumbing to make everything work. So you see, it is all about perspectives and the understanding about each one's platform, right? So I think that's the message that I would like to give you before we move forward to the content. So we have three main objectives, right? There's a lot of content to cover here, so I'm going to try to be as focused as possible. Even though you can throw your questions in the chat, I'm going to keep looking here. And if you ask any questions, I'll try my best to answer them as we go through the presentation, right? So we're going to start discussing black box versus white box instrumentation. I think this is a very important concept that you have to understand while working with OpenTelemetry, and more importantly, while you are planning your observability implementation strategy, right? And then we're going to actually walk through in some of the knobs that I have found in my experience that, man, it saved my life. I honestly can say that some of them, I would not be possible to actually move forward with my implementations if it wasn't for those knobs. So I think that's the main contribution that I like to share here with you today. And lastly, I'm going to discuss a little bit about how can you actually debug. I call it debugging the debugger, right? So what this means is that there's a way for you to actually debug the OpenTelemetry agent for Java. So and I'm going to show you how you can do this, right? So let's start discussion about this concept of black box versus white box instrumentation. I see, I can tell you confidently that the very own definition about what black box and white box instrumentation means, it is the number one source of confusion for anyone that is trying to adopt observability these days. And let me explain why by explaining what black box and white box instrumentation actually means, right? So, and this is why I brought you two boxes here, right? So the first box, as you can see here, that has this question mark. And this is to illustrate the fact that some pieces of code that you might own or have or work with, maybe you don't have fully access to that code, or you're not supposed to have access to this code, or you don't have the rights to change that code. And that's the reason why you have to rely on some approaches or techniques that you are not going to go deeper in the code, but somehow magically you want that code to be instrumented, and signals from and telemetry data from that execution would be sent to an observability backend. So it is very common, at least what I've been seeing in the community, is for people to, all right, I'm going to not worry about the whole changing instrumentation of my code itself or the code that some developer wrote for me, and I'm going to just put some agents or middleware that's going to do the instrumentation for me automatically, right? A good example, two good examples, is whether you are working with Kubernetes or you are working with service meshes, right? So because now you can actually plumb or connect all the observability pain points, like as we call it, right, in the edges, right? So everybody, there's an inbound traffic that then you intercept there, and then every time you have an outbound traffic, right, you intercept that. But now you are basically collection everything that happens from start to the finish of your code, but you don't have a clarity of what's going on inside that box, right? So it is an approach that works, yeah, definitely. But that relies in a lot of assumptions, and the most important one of them is the granularity of your services, right? I think this is a very powerful technique, whether if you're using service meshes or Kubernetes, but if you broke down your services or your business logic into multiple small microservices, that the whole perception about how much time each one of those services took time, right, it doesn't matter anymore. So that requires you to actually create some broke down your domain model into multiple services. And that is not a reality for all the projects. So that's a precondition, in my opinion. The other strategy is using white box, right? If you understand what black box is, white box is totally the other way around. Like, you do have access to the code, or more importantly, you want to actually open the Pandora box and specifically create some points or instrumentation point throughout your code, right, to make sure that you are providing the visibility that the observability backend specialists they deserve, right? So, for example, imagine that you were a Golang developer, right? So one thing is to provide how much time it took one microservice that basically you start monitoring for the main function, right? But what if your logic is broken down into different functions, right? And maybe some of the functions might execute faster than the others. You do want, or you should want, to provide this level of visibility to your observability backend engineers, right? Because now they can have everything they need to understand, okay, all right, so this microservice here is taking like 10 seconds to complete, but out of this 10 seconds, this function specifically here that calls a database or maybe is communicated with some RPC endpoint, that's the outlier. So when you use white box instrumentation, you have that power, right? So this understanding is important for you when you adopt OpenTelemetry, because your experience is going to drastically change depending of if you are choosing or if you are being forced to adopt either black box or white box instrumentation, right? So that's another thing that I've been seeing people complaining about OpenTelemetry. Yeah, no, every time the visibility that OpenTelemetry is giving me is too limited or minimal. Yeah, because you are not providing some instrumentation points around hold your code. You're basically instrumenting inbound and outbound. So yeah, it's going to be limited. So you see another perception that you have to have while you're dealing with OpenTelemetry, right? And also, this is important specifically for Java developers or people that develop microservices or services in general in Java, right? So in my experience, and this is the first thing that I had to actually dig deeper to understand is, and by the way, that's going to be my very own first tip for you in this presentation, is that if you pick 80% of the Java developers that are starting their adoption of observability with OpenTelemetry, they're going to say, yeah, no, OpenTelemetry is very simple. I just have to download the jar file containing the agent from the OpenTelemetry project, and then I'm going to provide this agent as a parameter here before I actually provide the jar file for my microservice. That's it. Everything's going to happen magically and automatically. So, and this is supposed to be like this, right? I'm not saying this is wrong. Again, it's all a matter of perception. What you have to understand is that this approach works beautifully, but there's a couple gotchas that you have to understand. Number one is going to instrument automatically all the libraries and frameworks that are supported by the out-of-the-box distribution of OpenTelemetry, right? So that's the first. Maybe a specific vendor created a custom distribution, their own distribution that inherited some of the code from the main project, and they put some other instrumentation. Yeah, so we have a better coverage about the libraries and frameworks that are supported. But sometimes this might not be enough. Maybe you do have support for a specific library, but not for a specific version. In my case specifically, I had a use case where I was working with Spring MVC, which is a library from the Java world. And I had, in that particular instance, to use a specific release of Spring MVC, otherwise it wouldn't work for the developer standpoint, right? And the OpenTelemetry distribution was way ahead in terms of support of the releases. So I have to actually downgrade the support for it. So that's the type of thing that sometimes you have to worry about it. It's not so straightforward as, oh, just provide a jar file as a parameter, and there you have it. Everything's going to work magically. Again, perceptions, right? So one of the things that I've discovered is that you do have a way with OpenTelemetry to programmatically create everything that the agent itself is doing, right? So you might ask yourself, right, Ricardo, what's wrong with you? Why you had to actually programmatically do everything that the agent does for you automatically, right? So the situation that I had in mind specifically was I was using some microservices that was written using Quarks, right? Quark is a framework or a runtime platform that has been built on top of the Graal VM. For those of you that are not familiar with the Java world, this is what we call compilation ahead of time. So all the code is compiled almost natively. No, actually, it's not almost. It's natively per se, right? So the whole purpose is for the execution and the bootstrapping of your services, it becomes faster, right? So it's an amazing technology, right? However, there's one gotcha, and I just told you the gotcha. Because the code needs to be compiled and generate the binary ahead of time, right? The whole instrumentation process that the JVM agent provides for you, it wouldn't work, right? Because what the JVM agent does ultimately, right? While the JVM is bootstrapping, the agent is kind of doing some kind of a class loader augmentation and changing and registering some sort of interceptors or point cuts. This has to do with some programming style called aspect-oriented programming, right? So it's registering the aspects that needs to be observable, right? So, but if you use technology like raw VM or Spring Native or Quarks, it wouldn't work. And that's my experience. So, but I needed to provide OpenTelemetry instrumentation. So what I had to do, okay, I'm going to give up of using the agent, and I'm going to programmatically create my way out to register all the tracer provider, the propagators, and create my own tracers to do everything automatically, right? And I'm telling you all of this because the whole concept of this presentation is supposed to be about Java, right? However, if you are a Python developer or a Golang developer or maybe some C# developer, you might be looking at me and say, Ricardo, this is my way of life. I do this naturally because I write code in Go as well, right? I'm not that good as I am in Java, but I try to write some Go code sometimes. And Go, you don't have agents, so you have to programmatically construct and instantiate everything by yourself. So this is something that, depending on the programming language, you have to do anyways. But in Java specifically, if you are dealing with technology that requires you to have your code compiled ahead of time, this might be troublesome, and you might have to kind of give up of the whole magic of the agent, right? So there's a couple discussions in place about how to solve this problem in the OpenTelemetry community project. I can share the issues with you if you want it later on, but the reality is that today, this might be something that you have to worry about. Okay. Now let's talk about some of the knobs that I've mentioned before. I think the first three of them that I'm going to share with you today, they are very, very, very useful. Like think about like this: your development team, they are building the microservices or the logic, right? So, and this is an ongoing project, right? And meanwhile, or concurrently, you are helping them. When you say you, maybe you are the same person, right? But I'm assuming that maybe the person that instruments is different the person that's writing code. Although in reality, they can be the same person, right? But you know what I'm talking about. So let's say that at the same time that you were building your code, you were writing that, testing and everything, your project is being implemented, you are also doing instrumentation part, right? And because if you added some of the libraries from OpenTelemetry and you enable some of the instrumentation, your code stopped from working. So what do? You remove everything, you go back and do a rollback in the previous release where you did not have any instrumentation. No way, Jose, man, don't do that. What you can do is to, in a per piece of code basis, you can disable and enable and kind of go to the root cause that was what's breaking. Maybe ultimately it's your own code that's breaking, and maybe the instrumentation does clarify this for the class loader. But the point is, you can actually disable the whole instrumentation, the whole out instrumentation, if you use that flag over here, right? So by default, it's true, obviously, right? So because what you do want with the agent is, remember when I told you that the agent bootstrap all the libraries and frameworks that it knows how to work with, right? So let's say you were using a client for Redis, for example. Oh, I got here the Lattice framework, so I have support for it. So I'm going to create traces and spans automatically for every interaction with Redis because I know the framework. But let's say you are kind of, okay, I think that's something related to the Redis communication is causing the problem. You can disable only that automatic instrumentation and enable only the manual instrumentation, the ones that you created by yourself, right? Or you can do the other way around. You can actually enable only the automatic instrumentation, and you can disable all the instrumentations, right? When I mean instrumentations is, let me go back here to this piece of code. There's an example here. When you actually create your own tracer and your own spans, this is what I call manual instrumentation, right? And you use the span to decorate a piece of code that start and end. So if you want to isolate only that scenario, you can use this flag over here, the API enable. So by default is also true, but you can switch to false. Obviously, you're going to have to reload your JVM to take effect because this is a JVM parameter, right? And if you are familiar with instrumentation in Java with OpenTelemetry, you might have heard about the annotation called with span, right? At with span. So basically, you decorate a method, and then every execution of that method will create a span, a root child span that calculates the beginning and the end of the execution for you automatically. So you don't have to actually write a code everything. But if you want to disable only that part, you can also set the OpenTelemetry annotations enables equals false. So anything that has to do with the annotation with span will be disabled, right? So obviously the default is true. right? So this is important. Um, let me see if there's a, okay, so I'm just follow up here if there's some questions. Um, the second situation, actually the third, that I passed through and I had to find a way to solve the problem has to do with asynchronous flows, right? So let me give you an overview about what that means, because it's not very straightforward to understand at first. But once you understand, you're going to see that there's a lot of situations that you might see yourself going this with. So let's say, for example, that the famous use case, you do use technologies such as Apache Kafka or RabbitMQ or Apache Pulsar, so your microservices can communicate, right? So if that's you, it has to do with asynchronous flows. Or maybe you are dealing with some sort of a library or programming language or architecture where everything happens asynchronously, like the execution of a single thread, right? There's the concept of handover, right? One thread finishes and then the other thread picks up and continues the processing. It's not very hard to understand, like technologies like a Vertex or maybe Node.js, where everything has a single thread model that dispatches events, and then you have to have all those kind of handovers and continuations all over the place, right? So that's why I brought you the picture here of a broken bridge. Like, and this is exactly what it means, because there's one thread executing code, and then that thread finishes, right? But then asynchronously or in batch, ETL batch is another example, is a great example. Maybe you have one piece of code that picks up the data from a source and store into a data lake. And then another microservice, another piece of code is going to pick up the data from the data lake and continues the process, right? So what is the problem here? If you don't do nothing, right? If you don't do absolutely nothing, everything will look like broken in the observability backend. For whoever is looking to the timeline of events in the observability backend, they're going to see, okay, I see that this code here, stop it here, but where it continues, I can see here, like, because you have to provide the continuation, right? For whoever sees the observability backend can understand the flow of things. So you name it. Either if you are using some polyglot concurrency, like maybe you are dealing with multiple programming languages, Java, Go, C# or .NET, C++, and then the threading models or the concurrence model for each programming language is different, right? So this is one of the things that you have to worry about. And the OpenTelemetry project, the agent itself, right, it allows you to use something that we call the text map propagators, right? So before I move into this, let me just make one thing clear, right? You might be thinking right now, like, Ricardo, I had never heard about this problem or text map propagators. Why are you telling me this then? Maybe, remember, everything has to do about perceptions. Maybe your reality, in your perception, you've always worked with synchronous technologies, like such as, for example, a microservice that exposes a REST endpoint. This is synchronous, right? A microservice that exposes a gRPC endpoint. This is also synchronous, right? So all the execution of the code happens in the context of the same request thread execution, right? So you don't have to worry about, you wouldn't have to worry about any of this, right? But in the situation where you might have like handovers or communication between multiple microservices, this is a problem that might occur, and that's where you should like take a note of the support of text map propagators. Like, just remember this, or how do I solve the problem of asynchronous flows? Text map propagators. Okay, create a dictionary or a hash map in your brain to remember this. Like asynchronous flows, text map propagators. That's it. The good news is that for synchronous flows, there is some built-in text map propagators in place already. That's what the agent does for you automatically. But for situations where you have to kind of propagate by yourself the execution of the code, as we call the context, right? You do have an API for this, right? Remember, what is OpenTelemetry? There's a bunch of APIs, SDKs, and tools for you to solve the problem of programmable observability, right? So there you have it. You have an API to solve this problem. It's a solved problem. The only thing you have to do is to write the code for it, right? And obviously, the SDK is going to be different for each programming language. I brought you some examples here, like one in Java and another in Golang. This is actually an example that I've built and I've published on my GitHub. So this is the link, right? You can copy it right now. So I'm I'm going to actually put this later on the chat so my friends can share with you. And but this is an example of a microservice, two microservices, one written in Java, one in Go, that communicates with each other through streaming/messaging technology called Apache Pulsar, right? So what it does is to use this context propagation, use the text map propagator. So take a look in the code. It's very straightforward to understand, and then you might have an idea about how to solve this problem to your own context, right? So that's one of the ways you can solve this problem. Okay. All right. This is another thing that I think is pretty cool, right? But is also dangerous, right? So I think the point of sharing this with you right now has to do more about how can you protect yourself from some hijack of data than actually something else, right? The whole point of this parameter that we call instrumentation, common, DB statement, sanitizer, enable, blah, 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 is a very long name, right? That's why I wrote it down here for you. It's because by default, right, everything that has to do with sensitive data, like passwords in a database, right, is going to look like in the logs or in the events like this with the question mark. And this is what we want, right? The last thing you want is to have your customer passwords, their credit cards, or any like sensitive data kind. Because let me take one step back and explain what's going on here. Like, remember, instrumentation is all about inspecting the execution of your code, pick up and collect some pieces of data that will be used for observability analysis in the backend. It's going to copy that, is going to transmit to observability backend, and that the copy of that piece of data is going to be stored there. So this is the perfect place to hijack data, right? And I'm not saying that OpenTelemetry is bad then. No, but not, by all means, it's not bad. That's why they give you the possibility for doing this. What you have to pay attention, and this flag by default is true. That's the default because you do want to sanitize all your sensitive data. But if you ever see any deployment, a bash script, or maybe some YAML configuration file from your Kubernetes manifest, that someone is twisting that flag to false, that's a highly secured risk. And I've seen situations where people hijacked critical and sensitive data because of this, right? So keep that in mind. It's more about for you to have awareness that this is possible, other than, oh, no, this is a flag that I'm going to use on my daily basis. So you're most likely you're never going to touch this. But you have to be aware that someone, knowing how this works, might twist that flag for you automatically, right? So take a look at this, okay? Thank you, Carl Klein, for sharing the URL in the chat. I didn't provide yet, but you went forward and do this, and I appreciate, right? So another problem that I've faced in the past was, right, so like I said, instrumentation is all about having these agents running co-located side by side or embedded in along with your code that is observing everything that happens during the execution, and then they are going to create traces or create metrics, track logs from everything that's going on, right? And this is great, right? That's the beauty of OpenTelemetry, right? However, when you start developing and instrumenting your code with OpenTelemetry, you might see that, okay, for a simple hello world, this is not going to be too noisy, right? Because the amount of data generated is going to be kind of a predictable and not so high. But when you, for example, do a simple test. If you have a monolith application, bunch of lines of code bases, and you simply enable instrumentation there, if you enable, sorry, this is my Alexa device. Alexa, stop. If you enable that, you're going to see that, wow, that's a lot of things going on behind the scenes. And it is not just about the noise. It is also about the performance optimization, because remember, it is data being instantiated within the process of your code, transmitted over the network, and stored into a storage, right? So this is infrastructure cost, right? So this is CPU cost because your application is processing too much data. This is going to be network cost because data is being transmitted all over your VPCs and all of those network channels. And there'll be storage costs because all the data is going to end up somewhere, whatever the backend stores that data. So what you do want to do, right, to make sure that you are collecting only the relevant data, right, is to use this flag here to exclude, because I'm from Brazil originally, so sometimes my accent speaking English goes away, to exclude the execution of certain classes, right? So what I mean by classes, if you're not a Java developer, everything in Java is a class, right? So that's where you put your logic of your code. So if you know what classes or packages or specific methods of a class that you were not interested because it doesn't provide you any value, so you can actually use this flag here and mention them. They're comma separated parameter, right? Sometimes it's not very useful because you might have a very long list of classes that are not supported, right? But this is very useful because certain frameworks are supported, but for the sake of, okay, what I am actually trying to collect and observe here on this microservice application is not interesting. So this is especially true for some low-level frameworks from Java, such as Natty, right? So Natty is a good example of, okay, I don't have to kind of collect and create spans for every single network communication there is. Or another example, JDBC, right? So whether if you're using Hibernate or JPA or any other persistent framework with your Java application, ultimately, they're all going to establish JDBC connection with your database. So you don't want to actually generate a span for every single JDBC connection execution of your code, you know? You want to keep things like high level, right? Unless, of course, you do need to explicitly show all the JDBC connections. This is possible, okay? But this is a parameter that you have to, I would suggest you to keep in mind, okay? Let me just keep track of the time here. Okay, I think we still have some time. Another very important parameter, or should I say, set of parameters that I would recommend you very hard to take a look at it is the sampling strategy, right? So let me explain how sampling works in the instrumentation and observability workloads. When you were starting to work with instrumentation, right, and you pick up the agent and you execute along with your microservices, and all of a sudden you see all those traces and spans being transmitted to the backend, and you see, wow, everything is great, it's automatically being created for me. Yay, I don't have to do anything else. Kind of you have, because what happens is that, like I said before, ultimately everything has to do with infrastructure cost, right? You don't want to have a huge amount of traces and spans being generated, transmitted. Generated has to do with CPU, transmitted has to do with network, and stored has to do with storage, right? You wanna throttle yourself about this, right? So one of the things that happens is that how the actual traces and spans are created. That's where the sampler, right, comes into play. So the most simple sampler, if that make any sense, and that sounds redundant, right? The most simple sampler is, all right, if I have 1,000 executions, for each execution, one spans will be generated, right? So there you have it. Like you're probably going to have it's going to be shatty, right, if you do this, right? So let's say you're not dealing with 1,000 invocation. You were dealing with like 1 million of invocations per second, per minute, per hour. So, okay, you don't want to actually collect all of this. And let me tell you the secret here. You don't have to, okay? For an actual observability implementation, for you to kind of come up with a conclusion that where's the bottleneck or unavailability source of a specific part of your code, you don't have to collect everything. You have to do samplings, right? So let's say, for example, that for every 1,000 invocation, you collect 40% of them. This is a sampling strategy. This is a tuning that you can do and the configuration using those parameters, right? And there's a lot of, there's officially in the OpenTelemetry project, there's 3 samplers supported, right? And if you go to documentation of the project, it's all there, right? But what is important for you to understand is that for each sampler, let's say you pick up one sampler, right? There is the sampler arguments. that you can extra turn all your execution. So make sure to not leave this by default, right? Because in the end, when you go to production, you do want to make sure that you are not going to have skyrocket all your infrastructure and networking costs, because your sponsors, your stakeholders, they are going to thank you for this because you are saving them money. So I think that's something that you should do proactively. All right. Another very important thing. This is not a big deal, but at least I found it wasn't happened with me, but someone from the community. I once was helping them, this specific company, in their observability implementation, and then they were afraid about the one-off type of style of adoption of the observability, right? And what I mean by one-off, right? They had experiences in the past about, all right, in the past we've adopted this APM vendor here that asked us to install all these agents and include all these libraries and SDKs and all of that. And then all of a sudden we became kind of a I'm not gonna use the word hostage, but it's not hostage. I think the word is we've became so tightly coupled with that particular APM solution that taking it off would require a huge engineering effort, right? Lots of releases or cycles to taking it off just for the sake of, okay, I want to check what happens with the behavior of my code without instrumentation, right? So let's say you find yourself in this situation. You want to see how your code behaves without instrumentation. With OpenTelemetry, whether if you're using the agent in the automatic mode or programmatic mode, you don't have to remove any of the libraries, the SDKs, or the agent itself in order for you to simply switch it off. Use this flag over here, right? So you can simply disable the agent, right? And everything will be kind of a disable, and your code will be executed without any observers, right? So that's a way for you to avoid not using a lot of engineering cycles for this, right? Okay, so I've been told that we are out of time. So this is one last thing that I would like to tell you, which is this. There's a way for you to plug and generate JFR events. If you're a Java developer, you know what this means. And then in your OpenTelemetry observation, and then you can actually extract this and use the JMC console for observing all of this. So just keep that in mind, and I will let you test this out later. So since we are out of time, and my apologies for not covering everything. Actually, there was only one slide that I didn't show you, so I think we did a good job here today. But even though, I would like to thank you, everybody, for staying here with today, and I wish you enjoy the rest of the conference. So
awesome. Thank you so much, Ricardo, for giving us such an amazing presentation on the OpenTelemetry agent. You've got me properly hooked. It's not something that I had personally given a shot before. We do have quite a few questions in our Q&A, so if you'd love to jump in on the hop-in and give the guys some answers, I'll drop all the questions here for you as well.
Yes, please. Yes.
Awesome. Thank you so much. And on that last note, I want to invite everybody that's still sitting here with us and listening intensely to come join us in track 1 for our closing keynote. I also just want to give a special shout out to our head event organizer, Carla. Without her, none of this would be possible. So Carla, you are an absolute legend.
Yes, you rock, Carla. Charles, you also did an amazing job throughout this day. Thank you for doing it with me and supporting me along the way. It's been so much fun to host this track with you. So let's drop my character finally. Let's hide the wig in my wardrobe out of cat's reach for this year. And yeah, we'll hope to see you next year in the next What the Fuck is SRE.
Thank you so much, Sevi, and it was amazing co-hosting alongside with you, and I'm sure we'll get our chance to host together again. On that note, everybody, I'll see you guys over in track 1. Have a lovely evening.